And so if you look at this, a definition of an identity is an equation in which the left side is equal to the right side for all values. Okay? It's an equation in which the left side is equal to the right side for all values. That's what an identity is. And so we're going to look at various things throughout this section as to how to solve for identities, proving identities. And so it's going to be one of those in which you're going to definitely want to pay attention. If you pay attention, they aren't going to be that bad. Okay? Whereas if you don't, you're going to probably struggle if you have to try and look in the book and gain all this information yourself. So first of all, let's review a little bit. What can you tell me about tangent? What would be something that tangent would equal? What would be an identity here? What does tangent equal? Okay, you're getting closer. Something like opposite over adjacent, but not those terms, because that only deals with right triangles. Yeah, what did you do to find the blue sheet tangent? What was one thing you did?
1 over cotangent.
1 over cotangent. Okay, let's think a little bit more specific. When you did your blue sheet, right? What did I tell you to do to find tangent? I said all you need to do is find
cosine.
Take what?
Sine.
Take sine divided by cosine, okay? And so that's what we're going to do here, okay? Tangent is nothing more than sine over cosine. That's an identity, okay? Those two are equivalent. With that in mind, what would cotangent be?
Cosecant.
Cosine over sine. Cotangent's going to be the flip of those. And this is going to be something that you're going to need to remember. You're going to need to kind of file these all the way to memory because you're going to have to kind of recall these pretty quick. Okay, cosecant. Remember, cosecant is 1 over sine. And secant is 1 over cosine. And so we actually call those reciprocal identities. Okay, it's not, you don't need to know that they're reciprocal identities, but they are because they're flipped. So we're going to start with kind of the first part of today. And it says if cotangent x equals 2 over 5 root 5 and sine x equals root 5 over 3, our task is to find the cosine of x. Okay. So if cotangent of x equals 2 over 5 root 5 and sine x equals root 5 over 3, find cosine of x. So let's think back to that first slide. That first slide says cotangent, and we know that cotangent equals what over what?
Cosine.
Cotangent of x equals cosine over sine. So I'm just going to plug in because I know 2 of the 3, right? I know that cotangent is 2 over 5 root 5. I know that cosine is what I'm trying to find. And I know that sine is root 5 over 3. So now all I need to do is solve that for cosine. And so what I could do is I could cross multiply. That's one way. Okay? The other thing that I could do, all right, since this is divided by root 5 over 3, I could multiply it by root 5 over 3. Can I do that and they would cancel? Because this is just like if it was cosine x over 5, you can multiply it by 5. All right, so I'm going to multiply this by root 5 over 3. Ah, the root 5's cancel off. Isn't that nice? And so what does that leave me with? 2 over 15. Very good. That's the answer. It told me to find what cosine x is, and cosine x equals 2/15. All right, so let's go ahead and look at the next slide. Okay, if cosecant of beta, now that's a Greek letter beta. Okay, it's just a b, so you could put like a squiggly b, equals 25 over 7, and secant of beta equals 25 over 24. Find tangent of beta. Okay, now this is for those of you that are kind of puzzle solvers. You're going to like these because these are kind of like puzzles. Okay, and so I think about, I need to know what tangent is. And I know that tangent tells me what? Sine over cosine, good. And so I need to think about, okay, I need to know sine and cosine in order to find this, but I don't have sine and cosine. I have cosecant and I have secant. So is there some way I can somehow manipulate those? Yeah, so what are you telling me? So I know that the sine of beta is what? 7 over 25. How do I know that? You flip them. They're reciprocals, remember that? And here secant, what's its buddy? Cosine. So really, I know that the cosine of beta is 24 over 25. And so now I need to find the tangent. So to find the tangent of beta, that's going to equal sine over cosine, which in this case, sine is 7 over 25, and cosine is 24 over 25. Now I'm going to show you a little trick. Okay, when you have two fractions like this, a fraction over a fraction, what you can do is if you look at the denominators and they're the same, you can actually cancel those out. And it's going to leave you with, in this case, 7 over 24. That only works if the denominators are the same. If they're not the same, you're going to have to do like a division sign. You'd have to do like this. 7 over 25 divided by 24 over 25, and then multiply by the reciprocal. But this is just a shortcut. You're going to find that this happens a couple, more often than not, and you can just cancel those, especially with these types of problems. All right? So let's go ahead and write these down. Now, these are really, 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 really important. You need to file these away to memory, especially those of you that are going to take calculus next year. This top one is one that you will need. And for the rest of you throughout the semester, this is one that you're never going to want to forget. Sine squared x plus cosine squared x equals 1. Now we can actually derive the other two from that first one. Okay. We can derive the other two from that first one.
Is there any reason why there's lots of spaces or the one?
No, that was just how I typed it in.
Because I put the space.
No, there's no reason. What it is when I enter things into my equation editor, it keeps the columns all the same because I did this all in one lump one instead of 3 different equations. All right, so file those away, especially that first one. Now what I'm going to do tomorrow to start class, I'm not going to do it today because I do know there are some people gone, but we're going to derive the other two. Okay, and it'll take us not even a minute or two. So let's go ahead and look at this next one here. It says if cotangent x equals -3 and cosine x is less than 0, find cosecant x and tangent x. So we're going to be drawing more triangles. Okay, more of these triangles. And so if you have that sign chart handy, that one where we have like quadrant 1, 2, 3, and 4, and we had like plus, 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 and we had like plus, minus, 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 plus. Yeah, it should be in your notes.
Oh, yeah.
And the quadrant 1 should say like sine plus, cosine plus, tangent plus. Quadrant 2 should say like sine plus, cosine negative, tangent.
Right there.
Okay,
Found
good.
it.
Somebody found it. All right, good. What was it by?
It was
Reference
by
angle.
Reference angles, okay?
And that's
So if you're
fine.
trying to find that back in your notes, that's what we're going to be using. Now notice what this says, if cotangent x equals -3. So cotangent x equals -3, really, what does that tell me that the tangent of x equals? -1/3, right? Okay. So let me think, tangent is negative and cosine is less than 0. So what type of value do I have for cosine if it's less than negative? So I'm looking for the quadrant, where is cosine negative and where is tangent negative? in quadrant 2. Okay, cosine and tangent. So basically, that means those are all gone. Okay, so I cancel out all of those. And so that leaves me with quadrant 2. And so let's go ahead and draw in a triangle here. Okay, tangent is negative 1/3. So what does that tell me? Opposite over adjacent. Now which one of those two is negative?
3.
The 3. Okay. The 3 is negative because of where it's located. So then now I need to find the hypotenuse. What's the hypotenuse going to be there, folks? And how can you find it? Pythagorean theorem, yep. So you have 1 squared plus 3 squared equals c squared. What's 1 squared? 3 squared. So answer is 10. So really you have root 10. Okay? So you have root 10. So now, if I'm going to find cosecant, because I already found tangent, right? If I'm going to find cosecant, what do I need to find first? What does cosecant go with? Cosecant goes with what? Sine. So I know that the sine of x is going to equal, which is what? Opposite over what? So 1 over root 10. You are kind of doing all of them. Now I don't want to simplify this because what's cosecant going to be? Root 10 over 1, right? Cosecant is just going to be the flip of that. And so this is one that you don't really want to simplify this because if you flip it now, it works really slick. It's going to be root 10 over 1 or root 10. So there you go. So you're doing a lot of the reciprocal relationships. You're still doing some of the same stuff we did, so it's not totally new. Okay, so we already looked at that one. Oh, cotangent x equals, yeah, we already looked at that one. So let's go ahead and look at this next one here. If sine x equals 1/6, then cosine x is greater than 0. Find cotangent and secant. So we need to determine what quadrant we're in. What quadrant are we in and why? Because both are positive, right? So we're in quadrant 1. Okay. So let's draw a triangle. Sine is 1/6. So what does that tell me? Yep, 1 over 6. So let's kind of try and do this in our head. What's 6 squared, by the way? 36. What's 1 squared? 1. So what does this have to be? Root 35. Okay, for those of you that are kind of wondering, if I were to square these, this is what I would get, right? So 1 plus what is 36? The answer is 35. Okay, so that's kind of one of those things that if you want to start working those in your head, that's fine. If not, go back to the old standby. Just kind of trying to show you some techniques that might help you do some of those in your head. Okay?
Oh, that's right.
All right, so now I need to find cotangent and secant. So to find cotangent and secant, I really need to find tangent and cosine. Okay, so what's tangent going to be?
Root 35.
1 over root 35, right? But I want to find cotangent. So what's cotangent going to be? Root 35. Oh, that was a nice 5. Let's try that one again. There we go. Okay. So now we've got secant. So to find secant, let's find cosine first. So what's the cosine going to be? Root 35 over 6. But I don't want cosine, I want secant. So what is secant? Yep, 6 root 35 over 35. For those of you that are wondering how on earth did we get that? Okay, we flipped it, and we actually get 6 over root 35. And remember, we need to flip-flop that. We need to get rid of that root. Okay. So kind of try to do some of these in your head. Okay, we've only got a few more to go and we're done for today. We're only going with 11 slides. Okay, so let's go ahead and look at this one. This says to simplify cosecant secant minus cotangent. Now this is really, really important. Okay, so that other stuff was kind of reviewed. This is something totally new. And to be honest with you, these are like my favorite problems ever. So after some of these, some of you are going to think I'm really weird, and that's okay. Okay, but cosecant times secant minus cotangent. First rule of thumb, change everything to sine and cosine. Change everything to sine and cosine. Okay, that's one of the things to look for. So how can I write cosecant? Over sine, right? How can I write secant? What's secant? 1 over cosine. Okay, oops. Let's try and write that one again. There, 1 over cosine. Minus, what's cotangent? Cotangent is 1 over tangent or cosine over sine. Remember what I said, change everything to sine and cosine. Now in order to combine things, you need to have a common denominator. I don't have a common denominator here. I have sine, cosine, and I have sine. All right? So let's make this the same denominator. So what am I going to want to multiply by? So when I already have a sine, I need a cosine, right? So really, if you think about it, I now have 1 over sine times cosine, okay, minus, what's cosine times cosine? Cosine squared over sine times cosine. So now what's nice about having common denominators?
It's easier to multiply.
I can actually now just add the 2, right?
Yeah.
So really I have 1 minus cosine squared. So first rule, try to change everything to sine and cosine. Second rule, whenever you have 2 trig functions squared, or a trig function squared in the number 1, you try to substitute one of the Pythagorean identities in. So you had 3 Pythagorean identities, right? What were the 3? What was the one I told you never to forget? Sine squared plus cosine squared equals 1. Would you agree that the top here has 2 of the 3?
Yeah.
Okay, because remember, this one was it, sine squared plus cosine squared equals 1. So is there some way I could somehow make this green look like this blue on one of the sides? If I subtract cosine squared here, what do I have on the left? Sine squared. What do you have on the right? 1 minus cosine squared. Oh, so really, what does this 1 minus cosine squared equal? Sine squared. Okay. Now, that might be a little difficult for you to see right now. You'll become used to this in a little bit. Okay, and when I say a little bit, it's probably a couple days. Okay, but it's just one of those things. It'll take a while to learn. What do you know about each of the top and the bottom now? They each have a sign. So what can you do? Cancel. So what does that leave me with? Sine over cosine, but I know that sine over cosine is nothing more than tangent. So this whole thing right here is equivalent to the tangent of theta. Okay? So what's going to happen is when you go through these, you're going to be able to simplify down to one trig function. All right? It's 214 now, so it's 214. Okay? So we're going to look at actually probably about 1 or 2 more for today, and then I'll go ahead and have your assignment written down. Okay? Love these. These are just great. Okay, so let's remember our 2 rules. 2 rules. We look for sine and cosine, or convert everything to sine and cosine. And then the next rule is we look for a trig function squared in the number 1, or 2 trig functions squared. So I've got 1 over cosine times 1 minus sine squared. So first rule, convert everything to sine and cosine. It's already done, right? So let's look at the next rule. Do I have a trig function squared in the number 1? Yep, I do. Right here. So which one of the 3 does that one somewhat look like, or a little bit? Right, it looks like kind of like this one, right? Sine squared, and I'll do alpha. Because if you're probably wondering where does, you can interchange that. You could put x in that, and it's going to be the same thing. So how could I get 1 minus sine squared on one side? What could I do from this purple one right here? Subtract sine squared. So on the left side, what are you left with? Cosine squared. On the right side, what do you have? 1 minus sine squared. Now this is one of those things, are you going to have to write this down every time? No. You're going to start to recognize these, and so you might on the next problem know that 1 minus sine squared is cosine squared, and that's fine. Okay? In fact, that's one of those things that the more you do, the more you're going to recognize how they all work. So in place of 1 minus sine squared, I can now put cosine squared. Okay? What do you know happens? Cancel, cancel. What's your answer going to be? Cosine. There you go. Okay. It's just kind of like a puzzle. You're kind of working through a puzzle. You start with something big and you kind of pare it down. And I think I have one more. Let's see. Yep, I do have one more. So you know what? I think this is where we're going to pick up tomorrow. And so have that written down. And we'll start with this one tomorrow. And here you go. You can go ahead and get started on your assignment. Now, we're not done with section 5.1. We're actually continuing with it tomorrow. But for today, if you want to get started, 2 through 16, the evens, and then 22 through 31, all.